Learning objective C wants us to divide the rational expressions again, but this time they're going to be binomials or trinomials. This is very specific to chapter 9. So remember, what we start off by doing is everything kind of goes in parentheses on the top and bottom. Those are groups. Now before we start crossing off, let's change the division to multiplication. So I'm going to rewrite the 1, and I'll just keep it like that. I'll do 3x plus 15 in one group. If it's a monomial like this, one piece, you don't necessarily need the parentheses around it. Then multiply, I'm going to flip-flop this x fraction, so it's going to be 2x plus 10. 2x plus 10 is a binomial. Keep it in parentheses. Do not lose the parentheses on that. And then over x. Again, when we multiply 2, it becomes one big fraction. So naturally right now, there's not one group that matches. Of the 4 pieces, here, 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 and here, nothing's identical. So you want to stop and see if there's a greatest common factor you can pull out of anything. And that's the things in parentheses. So when I look at this one here, I notice I can pull a 2 out of it. When I look at this one here, I can pull a 3 out of it. So let's rewrite this by doing that. I'll keep the 1 there, and I'm going to pull the 2 out of here. So if I pull 2 out of there, 2 divided by 2 is 1x. 10 divided by 2 is 5. Okay. On the bottom, I'm going to pull a 3 out of here. 3 divided by 3 is 1x. 15 divided by 3 is 5. And don't forget there's a single x sitting there. Now we can obviously see x plus 5 gets crossed off. All that's left is 1 times 2 is 2. 3 times x is 3x. And that's our final simplified answer. Let's look at another example. Now we see a fraction divided by just a single expression. You can make a single expression a fraction, just put it over 1. Okay? Everything here is already grouped up for us, which is great. That binomial has parentheses, and so does that one. So let's just change it to multiplication. I'm going to keep the 3x minus 6 there, then do 5x squared. Multiply by 1 over x minus 2. Again, I'm going to make it one big fraction and stop and pause to see if there's any common groups I can cross off. I don't see anything common. In particular, I'm looking at this monomial to see if there was another x up here, but there's not. So now I'm going to try to pull out numbers, greatest common factors, maybe in here or in here. Down here, I can't pull out a common number or a common variable. But up here, I can pull out a 3. So let's take a 3 out of that. 3 divided by 3 is 1 in the x. Negative 6 divided by 3 is 2. And I don't necessarily need to write times 1 there, so I'm actually just going to get rid of that and reverse it out. Just erase that. It doesn't need to be there. Now I'm going to divide by, I have 5x squared, keep the x minus 2 in parentheses. Now these two binomials here do match. I mean, this is a 1x. This is the same as 1x if you want to. The 1 doesn't have to necessarily be there. So you can cross those off. And what we're left with is a 3, a 5x squared. Okay, let's look at another one. I'm going to go ahead and put it in parentheses and change it to multiplication at the same time. So I'm going to do x plus 5 over 3x. Change it to multiplication, flip it to get the reciprocal, and then do in parentheses 2x plus 10. Now, when I make it one big fraction, there is something up front I can take care of. These guys are just single monomials. You can just cancel those out like we did in chapter 6. So I'm going to do this. My eyes go to the 3 and the 6 right now. So I'm going to take a 3 out of both. 3 divided by 3 is 1. 6 divided by 3 is 2. Now here I have a single x. Here I have two x's. So I can get rid of this x, and I can get rid of one of these, which will leave me with a 1x there. So that's done. Now these two groups here, nothing matches. However, I can pull out a greatest common factor there, so I'm going to rewrite it. I'm going to keep x plus 5. I'm going to carefully look what I have here. It looks like I have a 2 and an x left over. Got to check my writing. On the bottom here, this 3x is all gone. Now I'm going to take out the 2 out of here. 2 divided by 2 is 1x. 10 divided by 2 is 5. When you have that one, this one simplifies quite a bit. the x plus 5's cancel out, and the 2's cross out. So all you're left for this one is a simple answer of x. Who would have thought this involved-looking problem would literally just equal the variable x? I want to look at two more of these. Now this next one, we have a binomial up here, a monomial here, and this is a trinomial. Again, I want to see a fraction divided by a fraction, so I'm just going to change this and put it over 1. Let's change it to multiplication. And look for natural stuff to cancel out. Nothing matches directly. Again, the only way I can cross off this x if there was another single x with an exponent floating around. I cannot cross this x off. This is one complete group, so I need an x minus 9 group, and I don't have one, so don't cross this one x out. The only thing I can do for simplification, it looks like, is factor this. And here's the rule. Anything in parentheses, look at those. Sometimes they can be simplified. This x minus 9 can't, but when you have something in parentheses and it's squared, odds are you can factor it. So I'm going to go in here. I'm going to keep the x minus 9. By the way, I'm going to make it one big fraction. And I'm going to keep the 2x there. I'm going to break this one up into two groups. Remembering my factoring. The x squared is first, so it goes first and first here, x and x. I need to find factors of negative 45 such that they're going to come back and add to negative 4. I might have to write these down. So 45, the first one that comes to my mind, right, 45 and 1. 9 and 5 is next. There are more, but I'm just going to start with that. Can I multiply to get negative 45 using this? What if I try negative 9 times 5? That's negative 45. Will that add to negative 4? Right here, it actually does. So my answer is going to be here, a negative 9 and a plus 5. It doesn't matter which order you put them in. And the odds are in this problem, you guys, because we had an x minus 9 on the top, I'm guessing there's probably going to be one down here that I have to cancel out. It's not necessarily guaranteed to be true, but the probability of that is probably pretty good. Now I can notice the x minus 9 does get crossed out. Be careful what's on the top. Nothing. So do you put a 0 or a 1? If you put a 0, technically the whole problem would disappear because anything times 0 goes away. What's up there is actually a 1, so do not miss that. So I'm going to rewrite it, and I just put the 1 on the top. Everything else is on the bottom. So the 2x is down here, and the x plus 5 is down there. Do not bring it to the top unless it sits up there originally. And that is our final answer. Okay, our last one here, I am going to again get us two fractions, so put it over 1. I'm going to put everything in groups. And then I'm going to change it to multiplication. And do the reciprocal. I'm going to make it one big fraction and look for natural groups that cross out. There's 3 groups here, and none of them match directly, so I cannot cross any of those out. However, 2 of them have things that can be done to it. I can factor this one, and I can pull something out of this one. X minus 6 is done. So I'm going to rewrite it. I'm going to keep the x minus 6 down here. I'm going to go ahead and just look at this one here. I can pull out a greatest common factor of 4. 4 divided by 4 is 1. Negative 20 divided by 4 is negative 5. Now up here, you guys, odds are up here there's going to be a factor of either 6 or 5 is my guess. Again, I could be wrong, but that's what I'm going to try. I can factor that. The x squared gets broken up into x and x. I need factors of negative 10 that will add to negative 3x. So there's a couple of combos, either 10 and 1 or 5 and 2. But it has to multiply to negative 10. So maybe I say negative 5 times 2. Well, negative 5 times 2 actually adds to negative 3. So there's our combination. Negative 5 plus 2. Again, it doesn't matter which one I write first. I notice when I do this, there's a natural group that gets crossed off, x minus 5. Write what's left over, x plus 2 on the top. Then I'm going to put the 4 first. Normally put coefficients or just single numbers there. And then x minus 6. Nothing else crosses, I circle, that's my final answer.